4 of random LeetCode problem, under an hour. We'll see how this goes. All right, start the timer. Okay, you're going to string S, which is going to be a concatenation of anagrams of some string T. Anagrams, like first letter. Okay. Concat of anagrams. Okay. For the minimum possible length of string T. Okay. Min length of T. Anagrams. Okay, let's read a little. Anagrams form abbreviation. Oh, it's not the first letter. Okay, never mind. Rearranging the letters of a string. AAB and ABA and BAA are anagrams. AAB. Oh, let's give an acronym. I'm dumb. Okay, right, anagram. Known to be in concatenation. What does it mean, concatenation of anagrams? Something. BBA. One possible string T could be BA. Sure? I'm confused. What do you mean? Is just finding the unique letters? That seems dumb. Okay, CD, there's 4 unique letters, so right. There's 1, 2, 3 unique letters, so 3. It's just finding the unique letters. What the hell? Okay. There's, okay. All right. Letters equal to set. Because we're just going to put all of this into a hash map and then check the size of it and return that. For C in string, or S. C or letters dot add C, then turn len letters. This cannot be the solution. Are you fucking kidding me? Oh shoot, I have to answer that. Oh, wrong answer. Expected 4. Why? I'm glad there's some more complexity. Okay, AABB. Okay, let's use this test case. I don't understand why though. Hmm. I'm confused. I don't understand. This is really just I don't understand the problem statement. Okay. Concatenation of anagrams, some string T. Okay. Concatenation of anagrams. Okay. Oh. Okay. Okay. I think I'm understanding somewhat. We'll see. BBA. One possible string could be BA because you do BA and then you rearrange BA to AB, and then you concat them. Mm-hmm. CDEF. Okay. ABC, BCA, CAB, BAC, CBA. Oh, BA, wait, yeah, BAC, CBA. So I think it's because you can divide this into sections of 3 that all have those letters. So I think just to test my understanding of the problem, let's say it's CC BA. I think it should return, I think it has to return 4. Yeah, expected 4. Okay, that's interesting. Hmm. Okay, I'm glad it's not that easy. All right. Now how do we do this? CCBA is, this is just a weird problem. Okay, so I'm gonna make the minimum possible string, right? So I'm trying to find like repeated sections within the string S. Okay, wait, so what is it? If I have, I still barely understand the problem. Wait, can I add more test cases? How do I add a test case? I don't know how to do this. Oh, there it is. Okay. So if I have ABC, right? And then A, is that going to give 4? Yeah, because does it have to be an even divisor? You have to use like the whole, it's just concatenation, right? So that means you could have a string ABC, but that wouldn't work because you would have to take only the A from the ABC for the second part of it, which would not be a concatenation. So depending on whether this returns 4 or 2 or 3, I want to see. It expects 4. Okay, okay. I see, I see. Hmm. Okay. So len letters is useful. Just, I don't know if I'll use it, but just for conceptually, the minimum possible length of of t, right? So obviously I would have to have all letters. Now, how do you ensure that the anagram actually works? So what you can do is, let's assume that I have a string, right? So let's assume that this is my string t. String t. I can feed into a function, check t, and I should probably look at the bounds, but I want to finish writing this up. So blah blah, and we say mm, so while I is less than n, or sorry, len s I is equal to 0. We're just looping through the first x characters, x being the length of t. Um, yeah, just add that in, I guess, or call it trial. Len be I inclusive to I plus len trial. We'll define that up here. Okay, which would mean, let's say there's 3 characters, right? So 0 plus 3, so that'd be 0 colon 3, which means 0, 1, 2, which is 3 characters. Perfect, nice. So this would be, right, so this and trial. So essentially, given this, well, let me add the plus first. I plus equals length. Let's say if it returns a boolean, return true, and then this. So the big thing that I need here is essentially all the letters in this need to show up in this. They need to be anagrams. These two need to be anagrams of each other. This and this, which means I need to ensure that I can do this pretty quickly. I'll like write a quick function, right? Let's say, I'm trying to figure out how I want to do this. I want to use O1, so probably some kind of hash table. Yeah, I think a hash table probably works. So we'll say um, Anna dict, anagram dict, go to bang. Let's actually, let's comprehension that. It would be, key would be C, false, for trial, for C in trial. So for every letter in the string trial, set an entry where it's the letter keys to like a Boolean value. Yeah, so that's that. And then we say now, maybe I'm putting too much work into just this function because I just want to conceptually understand it, and I might be able to use this in my actual solution. For I in, or for letter in, yep, okay. So if letters are not in anagram dict, turn false, else if anagram dict. Oh, what do I do if there's multiple actually of the same letter? Let's put in as a number. Hmm, how do I list comprehension on that then? Maybe a little wonky. Okay, let's set this to 0. Or actually, let's just leave it because let's make it clear. I don't want to do list comprehension for this one. For letter, we'll keep it simple. Trial if letter in anagram data keys. Let's do not in. Oh wait, I can just use a set default. Anagram. I don't know. I don't remember how it goes. Anagram dot set default. Oh damn. I don't really know. Okay, I don't really remember it, the syntax, so we're just gonna do an annoying loop or an annoying condition. But letter 9 in keys. Then we say this. I really should not have made the name this big. It's annoying me. Go to 0. Else letter plus equals 1. It's essentially a count of the wait, no, never mind. It's essentially a count of how many times that letter appears. for every unique letter. So then we do the same thing for this one. We say if the letter is not, so if you get a letter in this string that's not in any of the keys, because the key should already be finished. It's not in any of the keys, then return false. Okay, clearly we just cut it. Obviously something went wrong. If it is, then we check if anagram dict. Again, this name is pissing me off. Okay, anyway. Is equal to oh, I have to make another dict. Well, I guess I can. Oh, I can do a minus actually. Subtract for each one, and then yeah, that'll kind of save space. So if this is equal to 0, right? This won't make sense yet, but essentially, if the anagram dict, if the value in the anagram dict is equal to 0, then that means all the available letters or available number of letters for that letter are taken up. So if there's two A's and it's already 0, that means we've already used two A's when we're trying to make, there's already two A's in SI epsilon. So does not work. And thus we return false. I guess this technically is an elif, but they're all returned anyway, so it doesn't really matter. Else letter minus equals 1. There we go. And then after this loop, right, that has to happen. We have to also have to check if all of them are 0, if everything in anagram dict is 0, because you want to use up all the letters. This makes sure that you don't use too many, and now we have to also make sure we use all of them. So if for here's just value. If val not equals 0, turn false. All right. If it doesn't, then we just keep going and move on to the next section of the string. Okay. And then once that's all done, we return true. Wow, that was a long side quest. Okay, so how can I use this? Or rather, with that understanding I have, how do I use that on this, right? So I can take the number of letters, right, and I run it through. Okay, so what I'm thinking is I'll start with, oh, maybe okay. The current thought is using this check function, I can iteratively test out different t's, different strings t. So in order to do that, there's two different ways. I can either run it, and if it doesn't work, add a new letter, and run again, or add the missing letter, and then run it again, and then try again, and then iteratively build up, and then and then at the end, obviously it'll work when I add the final, when I add the whole string back together. So there's that. But I could also, I don't know how this would work with letters, but I guess I'll start a binary search it. So let's say letters to add t, that's the minimum value, right? The minimum possible length of t. the maximum possible length of t is going to be the length of the string, right? S. So I can say check the mid and then just binary search from there. The question is, instead of giving a trial letter, can I just, instead of giving trial, right, as in a string, can I just give a number and then somehow algorithmically figure out from there? So let's see, where is trial using my check function? Also, this makes a convenient use of my check function because obviously binary search needs a check. So I obviously use a len here. For letter in trial, that's the only time it's used. So essentially, okay. Okay, but since this is built from anagrams of t, yeah, one can say that all of the letters in trial are essentially the letters in the set. The only difference is the number of those letters. That's the stickler. How can I change this code so that it only looks at the number of letters? Okay, so essentially what my code is doing, I'm saying given a string trial, I'm checking if the string works. I think if I reorder this a little bit and I say this is the string, and then I build the anagram dict, I subtract using while I'm iterating through trial all the letters. Yeah. So I iterate through the list of unique letters and I subtract from the dict. And then, oh my God, I have it. And then all the x, so okay, for example, so we'll do, I'm just gonna hit command x. I should probably explain this out just for clarity's sake, but I don't want to lose this. Okay, so, right, let's say that this trial is going to be a num, okay? Trial is an int. So for every section, every five letters, I'm assuming trial is five in my head, so 5 letters of trial. For every 5 letters of the big string s, I'm going to check if I'm going to check if it's an anagram, right? How do I do this? Well, I iterate through every letter of that 5-letter string, and I build an anagram dict. I say, okay, these are the letters in the anagram, or these are the letters in that part of. Let's see, it's plus equal one. These are the letters in that part of the string, right? So if letter's not in anagram dict keys, then I say, hey, just make that equal to 0. If it is, then we just plus equals 1. So if anagram letter is equal to 0, yeah. Right? Nice. Oh, wait, equal to 1. That's actually a good catch that I remembered that. Shoot. Whew, that would have been bad. Okay. Okay. Yeah. So basically, it's just me counting the number of letters as well as, like, yeah, it's basically building a dict that has all the unique letters. And then from the non-unique letters, how many of them there are. So then we say, okay, trial is a number, and we know that this letter set is all the unique letters. So we say, okay, for L in letters, as in those all the unique letters, if this unique letter is not in the anagram dicta keys, then we return false, because every section of the string has to have all of these letters. right? So we just return false there. Else, um, right. Sorry, I'm not used to talking while coding, as is evident. For L letters, if L is not in any article keys, we return false. If it is, then we say, okay, that's cool. So what's next is that we should check. I think we just, yeah, I think we subtract one from it. So obviously, okay, not that I think this is going to be a problem, or not. This it theoretically should never go to the second check, but all right. So if it doesn't, wait. Well, I guess it could. No, wait, no. Theoretically, it should never go to the second check because these are all unique letters. But this is simply for, yeah. I actually don't. Yeah, whatever. Sorry, I take it back. I don't really know it. It is just unique letters. Um, else we say just subtract one, right? So oh my god, there we go. We take away that one letter. So if all the vowels in anagram dig values are equal to 0, then we're good. We return true. Because that means that, yeah, if at the end of this for loop, everything's equal, all the values in anagram dig values is equal to true or equal to 0, that means that, boom, it's an anagram, or this section is an anagram. So we can just move on, check the next section. If it's not, if one of them is not equal to 0, right, then that's where it becomes a problem. Because that's where we have to count for repeated letters. So what we say is we keep a count is equal to mm, oh, I've discovered another problem, but I will take this out. So mm, I'm brainstorming a little bit. So if it's not equal to 0, then s dot append key times val. So essentially, yeah. So if it's not equal to 0, so we haven't used all of them up, then we create a string of all the leftover letters. So it should be essentially repeated letters from this. So then we check, is if the len of letters, so all the unique letters, plus the len of the repeated letters is equal to trial, or I should write not equal because it matters, not equal to trial, then that means that the number of letters is wrong. It's not exactly the same, which is necessary for an anagram. So we return false. If it's not, then we somehow need these extra letters to carry over. And that's why I built this S string. So what we'll do, this is going to be a little annoying, I will say. Okay, I need these letters in S to carry over, right? So that means the building of anagram dict has to be modified because that's what. Hmm, yeah, I just want to add +1 to certain anagram dicts. just because you can't have the same, trial can't change. It has to be essentially the same string. So, given this, I think what I'll do is, maybe a little bit cheeky of me, I'm going to define anagram dict outside of the loop. Okay? You start with a blank dict. And then you fill it out according to these letters. And yeah, you fill it out according to that substring. You check, is it an anagram? Does it have every unique letter? Yes, it does. Does it have any leftover letters? Let's say yes, it does. What are exactly the leftover letters? Well, they're this, and the stuff in this string. Let's say it's AAC, right? And the full string was some combinations of B's and C's. Or some combination, right? It doesn't matter. So what I'm going to do is, I'm going to say, okay, cool. Now, for the next iteration, I want to ensure that these A's and C's are accounted for. So what I'm going to do is add, I can probably do it in this. Oh, wait. So essentially, what I was thinking was the leftover in anagram dict should be there when you start the next iteration of the while loop. Thus, when you run this again, um, oh, I was thinking once you run this again, you'll get back. That doesn't exactly work. I'm on the right track, sort of, but something I'm missing a little bit. Hmm. This time limit's really grinding on me, to be honest. I just want to draw something out, but I also do. This is supposed to be practice, so no drawing. Okay. So at this point, we have the anagram. The anagram dict right now is filled with the leftover letters, right? So, wait, what is this again? Len letters. What's that this? Oh yeah. That's fine. Okay. So the anagram dict is filled with the leftover letters. So when it goes to the next iteration, I want to ensure that the leftover letters are the exact same. So what I'm going to do is, I'm actually not going to do that. I'm going to say S is equal to, is there an outside, only lowercase, okay. So I'm going to say X, right? This is my default. This is like the extra letters string. So what I'm going to do is after this construction, I'm going to check if S is an anagram of S. Oh, there's got to be a better way to do that. I'll just make it a set of letters. No, then it won't count for numbers. I don't want to make another hash table. That seems like inefficient. But is it what I have to do? Ugh. I'll think about it. For now, we'll just call it strings. So let's say this is a string of AAC. Um, okay, so this was the first iteration. This happens. This I want to happen every iteration. This I want to happen every iteration, and this I want to happen in every iteration. This I also want to happen in every iteration, right? So once I'm at this point, I say, okay, so I have to account for all letters in this section of the string. Remove the unique letters, and now I have some leftover repeated characters that are in the string here. I've also checked the number of total letters, and it's equal to the trial string. So essentially, the string that would be made of all the unique letters plus the leftover letters is within the trial number that I've been thinking of, that I'm binary searching for. But now I need to check if the letters are actually the same. Obviously, the unique letters are going to be the same every time, just one of each letter. So I just want to check if the leftover characters are the same. And that's what S is for. So I have to check if I know this is going to be dumb, S is equal to S. Or S is not equal to S. Return false. Bang. Now how do we do this actual S equals S nonsense? Well, essentially what I'm saying is I want the leftover characters from last round to be equal to the leftover characters from this round. And this will serve as my, unless the leftover characters from last round is nothing, because we haven't done last round yet. That's what that big X is for. So if S is not equal to our big character, and yeah, so if it's equal to the big character, then we don't even worry about this check yet. And S, let's call this a different letter. Let's call this previous leftovers. All right, let's call this Let's call this carryover. I like that. Carryover. So if the carryover is not equal to X, and carryover is not equal to S, then return false. But obviously the order is going to be different, so we we do need to use the dict, which is all right. Oh, I actually don't think I need to store a dict because anagram dict at this point in time is going to be just carryover. It's going to be a bunch of zeros and carryover. So what I can say is, how do you make a copy of a dictionary? I can just use a. No, it can't be an ordered list. Let's just convert it to a list. I think of key value pairs, and then we iterate through. So I say, okay. Mm, I guess I am using S for the length, which I guess I could just make it a number. Num leftover. I need to speed up my coding, to be honest. I know this solution is going to work, but I just have not. I've been explaining everything out loud, so I've been really slow about it. So let's do val or num. Me and my long variable names. God damn it. Okay. And what I want to say is if the carryover or actually, let's see. So if carryover is not equal to none, because I'm just gonna make this a none type. Where is it? Where are you, carryover? There you are. None. Okay. For it's gonna be the same thing. So I'm trying to figure out how I can combine these two for loops. I guess yeah, I could. Let's add a boolean just because I don't want to check stuff. Passes or same letters equal to true. This will be our check. So we'll say if not same. I guess it's not same letters. Okay, so we'll set same letters here. So essentially for key value and anagram detect, we obviously are going to use the num, and it is not, does this not work? Or I'm just going to combine this into one big loop. Right? If carryover is not equal to none, then if carryover how do you clone a dict? Oh my god. I need a deep copy. I have no idea. If carryover I is equal to, no, why am I doing I? Key equal to, or I should just say val, are not equal, because we're checking for not equals. I know I could return false. Should I just return false? I think for now it just makes more sense. My head is going to break if I throw in a random return statement. Organizational wise, it just feels better. Okay, so that's what happens. Now I have to actually set carryover. So the first iteration, this happens, and then it goes through this. It ignores all the carryover stuff. It checks this, and then same letter is automatically true. So that goes through, and then says I plus equals length. So before that, it's a carryover. If carryover is equal to none, then carry over is equal to a deep copy of anagram dict, which I don't know the syntax for, unfortunately. So I will be Googling this. I did try to stay away from Google, but this just feels like a syntax issue. To make deep copy of dictionary Python. Use the, oh, I don't want to import a module for it. It doesn't exist. I think I have to import a module, as annoying as it is. There's got to be a more efficient way to do this, but right now I'm just trying to solve the problem, so we're going to leave it at that. I think if I convert it to a list, maybe that might be better. Or if I lexicographically sort the anagram dict, and then I use a list. Or if I sort it before I add it. Oh, that's actually so smart. I feel like I'm wasting time, to be honest. Oh, I should just do that for all of them. Why am I using dicts at all? I should just sort the anagram. Oh my god. But I really don't want to delete my solution. I have 15 minutes. Like, ugh. If it doesn't pass time, then I'll do that. But I can't right now. As it stands, damn, that is such a waste of time. That is such a waste of time. Or runtime, I should say. Okay, so that should work. Let's check the, now let's write out this quick little binary search real quick. Low is equal to len letters. High is equal to, where are my cursors going? There. High is equal to what? Len string, or len s, while low is less than, is it less than or equal to? High if low, or if, or let's calculate mid is equal to low plus high divided by 2. If check t mid. We're minimizing, so we say high is equal to mid. Is it -1? No, because actually I'm not sure. Else, if it fails, low is equal to mid +1. Yeah, I think low makes progress. Maybe they both have to make progress. We'll see. Just run it and see what happens. Anyway, and then we return low. Run. Ugh, all right. Line 19. Huh. What? Return anagram. Oh, why is it a return? Letter not in anagram keys. Yeah, I don't know why there's a return there. Probably left over from return false. Carry over key val. Yep. Let's get the syntax out of that and errors out of the way. Oh wait, it's not even mine. It's just trial. So trial. Wait, no, it should be here. Interesting. Is there an infinite loop? It's not going to take this long. It's probably the binary search. Probably mid -1. All right. Still taking too long. Is it because of this? Okay, I have to do a little bit of a print debugging. Print. It is. I have 10 minutes to finish this. I know I have a solution. Okay. Oh, 0, 3. Why is it going back to 0? Okay, we found the problem. Oh, I see. When it's not an even split. Wait. At 3. Right, so in while loop, let's say in while loop 3, So anagram, so it'd be 3 to I plus 3 is 6. So it should be 3 to 5, which is just 2 letters. I guess I can just return false if len s mod trial not equal to 0, return false. I don't think that was a problem, but yeah, it's definitely a problem with the actual while loop. Ugh, that is annoying. Oh, didn't you go to the in while loop part? That's interesting. That's so annoying. God damn it. I am quite annoyed. Mostly because of the time. I know I have this. I do not. I want this to be a success so badly. Oh no. Oh no. Oh no. Nice. Thank God for saving. Mid. 2 for 3. Oh, it's not monotonic. Oh my God. I hadn't even thought of that. Oh, that's so bad. That's not good at all. That's real bad. Hmm. Okay. That's quite sad. There probably is a way to make it work, but this deep into my time limit, I'm just trying to solve it. So we're just diverting to linear search. Low is less than high. Command V. There we go. We're just gonna skip those. We're just gonna linear search and skip the ones that are not um, easily divisible. So mid is equal to low. Well, we don't need that. Don't need this. If check mid. Turn. Oh, I didn't even have the right spelling. Return impossible, I guess. Which I guess should be high. We don't even need a high, but it's whatever. Oh, high is equal to len s. I can replace those. Output limit exceeded. 0, 2. Oh, it's this problem again. I gotta figure out why this is happening. Come on, 5 minutes to discover this. Where are you? I less than len. I wish, is debugging? No, debugging's not free. Damn. Oh, it's because all the return falses. God damn. I can't believe I missed that. This is what happens when you return early. Wait. Wait, return false exits the whole function. Is there a break? Oh, there is a break. Yep. Wait. this break should return false. And I don't know why it's not working, but we're just going to make it do that. Because how the hell did the break statement not go to the I plus equals trial? Yep, it's the same problem. It wasn't that. Okay, we're going to do some very primitive here. Do you make it past unique letters? Come on. All right, fine. We'll add it everywhere. Dang, I have 4 minutes. Can feel the time pressure crunch because I'm so close. Last one I failed, but I was not close at all. So in letter loop, in unique loop, done unique loop, in while loop 2, in letter, done unique, in while loop 0. So done unique. Do I reset I back to 0? Wait. Hold up. I have a sneaking suspicion here. Oh my god. Ugh, this. Okay, there we go. Starting to get it. Let's remove all these print statements. What'd you return? 4? Does it always return 4? Yeah, it's always returning. Oh. So this is never returning true. It should. I'm very disappointed right now. Trying to find out where exactly it keeps catching. So here it is. If carryover key is not equal to value. So let's print carryover and I feel I'm getting so close. Oh my god, I have 10 seconds. Alright, we're gonna go overtime, 10 minutes. It will still count as a fail, but overtime, just for my own sake. can't do in 10 minutes, then it's whatever. -1. Whoa, whoa, whoa. Also, first of all, why is there a -1? Should never be a -1. None plus A1B. Okay. That's fine. So letters, it's weird. What? Does minus equal not work? Is it B? Is an A? -1. Did you register B? I think I registered B twice. Why? Oh my god. Oh my god. I feel like an idiot right now. Oh my god. Come on. That's what it was. That's what it was. Oh my. There's no way. I hate it. I hate copy paste. Oh my god. No. That's so sad. I passed it. All right. I know this is way past time, but I do want to try the string thing. Well, I guess. Actually, no, that will be. I'll leave that to the recap um, video. So for now, we just solved it. Great job. Still fail, but 103.